Hello everyone, my name is Jose Rodriguez. Welcome to another video of our playlist dedicated to the credential dumping LSASS memory technique. Before we continue, it is important for you to understand that the steps that you will see in this video are just for educational and demonstration purposes. You must not use them against any real network. The LSASS memory technique has been used by real adversaries to access credential material stored in the LSASS in the memory of the LSASS process. Okay, we will use 3 virtual machines from our lab environment to simulate this attack: a Windows 10 system, a pfSense router, and a Kali Linux machine. If you would like to build a similar lab environment, please check the My Virtual Lab environment using VirtualBox playlist in our YouTube channel. We will provide a link in the description of this video. Okay, here you can see a list of the tactics and techniques that we will show in this video. Our victim, Poppy Godoy, will execute a malicious payload as an administrator user to facilitate the escalation of privileges. This is necessary because we are planning on migrating to a different process, okay, that might be using or running under the context of the system user, okay? We are getting system privileges by using name pipe impersonation techniques, okay? Uh, and the most important technique within this plan is the LSASS memory technique, okay? And we will implement it by using a Microsoft built-in DLL, the component services DLL, and we will use the PowerShell module from Metasploit. Here you can see the 3 virtual machines, Kali, pfSense, and Windows 10. And it is important to understand that the interaction between Kali and Windows 10 is going to be through the router, okay? This means that whenever you see the reverse shell connection from Windows to Kali, the source IP for that connection will be 10.055, the IP address of our router. Okay, so let's start by making our payload available for our victim. Okay, so let's go to our Kali Linux machine here. Let's open a terminal window. Let me increase the font size for you. And let's change our current user to the root user using sudo space su, then provide the password for Kali. Okay, and we will get network information by running the IP space a command, and the IP address for our Kali system is 10.0.5.13. We will use this information when creating our payload, okay? And we will store this payload under the var www.html directory, okay? Because we are going to use the Apache 2 server uh, that is pre-installed in Kali, okay, to make our payload available. So let's create our payload. We will use MSF Venom, okay? We will use the -p parameter to specify the type of payload we want to create. So it's gonna be Windows /x64 slash meterpreter slash reverse underscore HTTPS, okay? And then we need to specify the listening host. In this case is Kali, so we will use 10.0.5, 10.0.5, 13. And we also need to specify a listening port. You can use whatever port you want. I will go with 5, 6, 7, 8. And then we need to specify the format, okay, with a -f parameter, the format of our payload. And now I will go with exe for executable. And then we need to store this payload, as we mentioned before, in var www HTML, and then you can use whatever name you want for your payload. I will go with Windows or WinX64 underscore payload, okay, .exe. This directory, var www.html, is the default directory for the Apache 2 server files, okay? Okay, so the payload was created. Now, as we mentioned it before, we are working with the Apache 2 server, web server, um, that is pre-installed in Kali. So we need to start that service, okay? And we will do that using the system CTL, okay, start Apache 2, and that's it. So if we go to our Windows 10 machine, and if we open a new tab in your preferred web browser, if you go to 10.05.13 or the IP of your Kali system, right, and you hit enter, you should see the default welcome page for Apache, okay? Unlike our Python HTTP server, okay, we don't have a link to click on it, okay? So the way we are downloading this payload is by just adding to the URL 10.05.13 a slash and then the name of the payload, which is winx64 underscore payload .exe. Hit enter, and the download process should start. Let's just give it some time here. Mhm. So as we mentioned it before, once the payload is executed, a reverse shell connection will be received by our Kali system. However, in order to handle that connection and start an interpreter session, we need to configure a listener on port 5678, the same port we use when creating the payload. Um, and we will use the Metasploit framework to configure this listener. Okay, so let's go back to Kali. And let me clear the screen here for you. And before we start the Metasploit framework, okay, we need to run some commands. We need to use systemctl space start PostgreSQL, okay? This service will help us to manage the Metasploit database, okay? We also need to run msfdb space init to create or just validate that the database is already created for the Metasploit framework. Yep. So the database is already started, it's already configured. So we can now run msf console, and we will use the -q option to start the framework in quiet mode. Okay, so we don't see the entire introduction message. Uh, we just need access to the framework. Okay, so Metasploit is ready. So we will use the multi-handler module, okay, to configure our listener. As you can see, the default payload for this module is generic slash shell reverse TCP. So we will need to update that and use the correct payload, okay? So if you run options, here you can see all the information for this module. So we will need to specify the right payload, the right listening host, and the listening port. Okay, remember that these values should match the values you use when creating your payload. Okay, so I'll go with set payload, and we will use Windows slash x64 slash interpreter slash reverse underscore HTTPS. Okay, Now we need to specify the listening host. In this case is Kali, so we will use 10.05.13. And we also need to specify the listening port, which is 5678. And then we can execute this module by using the run command. Okay, great. Our Kali system is now waiting for Puppy to execute the payload file. Okay, so now we can continue with the second stage of our simulation plan, okay, which is the execution of the malicious payload. Okay, so let's go to our Windows 10 system here. Okay, so here's the payload. It was downloaded already. So let's click on the show in folder option, or just open a file explorer window and go to wherever you downloaded the file. So here's my payload. I'll make right click on it and then run as administrator. Since Puppy is not part of the administrators group, okay, you will get this user account control window that will ask you for the credentials of a domain admin, okay? So we will use pedro.gustavo, and then the password. So now the payload is being executed. So if we go back to our Kali system, let's wait for a interpreter session to be created, okay? As you can see here, the connection we are receiving is from 10.055. That's the IP of our pfSense router. And yep, interpreter session was created successfully, okay? So now that we got initial access to our victim machine, we can start the discovery phase of our plan, okay? So let's start by opening a shell on the top, on the victim's machine, okay? And let's run system info to get info context about this, about the device. So you can see the information about the operating system. You can see directories like Windows and system directories, the boot service, or sorry, the boot device. And you also have information about the network card of this computer. As you can see, the internal IP address of this computer within the pandalab.com domain is 192.168.142. We can also get information about the user by running, let's run two commands together, okay? Who am I? And then who am I slash groups. And as you can see, we are running, this interpreter session is running under the context of pedro.gustavo, and this user is part of the domain admins group for the pandalab.com domain, okay? This means that we have access to this system with high privileges, okay? Now, let's look for processes running under the context of the authority system user, okay? And we will use the task list utility. We will specify the format output as table. Okay, let me reduce the font a little bit. Table, and then we want information about the services, SVC, okay, for those processes. And then we will add a filter, okay, where the username is equals to NT authority backslash system. Okay, so these are all the processes and the services related to that process that are running under the context of the NT authority system user. Okay, the idea of this step is to identify a process that is more likely to access LSASS. Okay, for example, I will pick one randomly, but you should do your own research on deciding which service or which process is a better option to access LSASS. Okay, so I'll go with, let's say, this one. This is the Windows push notifications service, okay, that is running under the context of this SVC host process. Okay, if I'm not mistaken, this service usually doesn't uh, access LSASS, but who knows? That's not a general rule, right? Maybe in your system there might be a reason for this process to access LSASS. But again, I'm just picking this one randomly. Okay, so let's use let's take note of the process ID, which is 2924. We will use that information later during our simulation. Okay, so we just identify a process that we can use to access LSASS, but this process is running under the context of the system user, which means that we will need to escalate our privileges from admin to system. Okay, and we will do this using the get system module of Metasploit. Okay, so let's go here, and we will need to exit this shell by typing and running exit. Okay, so we are now in our interpreter session, um, and we will use get system. Okay, and we will use space dash h parameter so we can get more information about this command. We can use this command to attempt to get local system privileges. And as you can see, there are 7 different options to implement this module. Okay, it goes all the way from implementing all the techniques to specific techniques. Okay, so you have 7 options. The one that we will use for the purpose of this video is going to be number 2. Okay, named pipe impersonation dropper admin. Okay, so the way we execute this is we will do get system. Okay, space, we need to specify the dash t parameter. Okay, and then the number, in this case is going to be number 2. Okay, and then just hit enter to execute that module. Metasploit will create a service to execute a system, and then it will feed data into this service through a name pipe that is randomly created by the malicious payload. Okay, if you want to validate that your session is running under the system user, okay, you can run get UID, and as you can see, the execution was successful. We are running not under the Pedro del Gustavo context anymore. We are running under the context of the NT authority system user. Okay, so since we got system privileges, right, we can now migrate uh, from our current process to the Windows push notification process. Okay, and if we go to Kali, okay, we are going to run the migrate command, and then we need to specify the process ID. And the process ID that we identified before was 2924. Okay, and then just hit enter. So after the execution of this command, our malicious payload will be injected into the Windows push notification process. Okay, so the migration was completed successfully. Okay, so now that we are running our payload under the context of this new process, okay, let's suppose that this process is more likely to access LSASS. Okay, now we can use the built-in DLL, the component services DLL, via PowerShell to steal credentials material. Okay, so let's go back to Kali. And we will load the PowerShell module uh, for Metasploit. So we'll do load PowerShell and click enter. Okay, so while this is loading, the commands that we will use are inspired by the Atomic Red Team project from Red Canary. So if you go to their GitHub repo, you will see under technique 10.03.001 for which is the technique ID for LSASS memory, you will see this code under the atomic test number 2. Okay, so just let me copy this really quick. And at the end, we need to specify the path and then the full option. Okay, so we will need to use PowerShell underscore execute space, then quotation marks, and let's copy the section of the command. So we need to specify the file path for the run DLL application, and then we have a space, and then the path to the component services DLL, then a comma, and then we're using the mini dump function. Okay, and this part of the command is basically getting the process ID for LSASS. Okay, and then we need to specify a file path for the dump file that will be created, okay, with all the information of the LSASS process. So I'll go with C, Windows temp, and I'll go with LSASS dash com SBCS. Okay, and then DMP space full, and then quotation marks. Okay, you cannot see the command here, but it's just because of the window size. But if the command was executed correctly, okay, if we open a shell and if we list the files, okay, under the C Windows 10 folder, you will see that here is the DMP file that we just created, okay, with all the information of the LSASS process. Not only the memory, but also the metadata, because we use the full option for the mini dump command. Okay, great. So let's exit the shell here. So we go back to our Meterpreter session. So now that we access it and install the credentials material, right? We are ready to exfiltrate this information. Okay, so let's go back to Kali, and we will use the download function. Okay, and we will need to run download space C colon double backslash Windows double backslash tempo folder, and then the name LSASS dash com SBCS dot DMP. Okay, you might be asking yourself, Jose, why are you using double backslash and sometimes just a single backslash? The reason is because this is I always use double backslash whenever I'm using the Metasploit syntax. Okay, whenever you are interacting directly with the Windows system, the Windows target, then you can use only one backslash. Okay, so let's just hit enter, and Metasploit will start to exfiltrate the information. Okay, so let's just wait until it gets until 100%. Okay, the exfiltration is complete. So as you can see, we have now access to the DMP file, and it is under the home Kali directory. Okay, so let's now that we have that file, we can access and get credentials material from this DMP file. Okay, and you can use whatever tool you want. I'll show you uh, how can you do this using PyPyCats, okay, which is a pre-installed utility in Kali. Okay, so let's exit our interpreter session. Okay, let's exit the Metasploit framework. Okay, so we are in Kali again. And what we are going to do is, let me clear the screen. Before we do that, let's just copy the path to the file. Copy. And let me clear the screen here for you. Okay. And you can just run PyPyCats. Okay. And then LSA, and then minidump, and then the path to the DMP file. Okay. Which is home Kali and the name LSASS dash comsvcs svcs.dmp, and then hit enter. Okay, so after you run the command, you can see information. For example, for Pedro.Gustavo, you can see the hashes, you can see the domain, you can see, even in this case, you can see the plain text password for that user. Okay, you have also information related to, let's see what else. Oh, here we have also information about the papi.godoy user. Okay, you have the hashes, and that's it. So great, we have successfully completed all the steps um, from our simulation plan. Okay, remember that all the data uh, related to this simulation will be stored in under the security datasets project, okay, from Open Threat Research, and we will share the links in the description of this video. Thank you for watching us.